Hi folks, Mr. Long here. I'm just going to go through a screencast on the different types of tangent problems. And these are all done with just quadratics to make it as simple as possible. And we're going to proceed from the least complex, type 1, to the most complex, type 4. So, and really there's only 4 types of tangent problems I can possibly give you. So first thing I want you to look at is there's a nice Desmo sketch here of the actual tangent. So there's your parabola right there, and then that's in red, and then the blue is the line of tangency. Okay, we call this point the point of tangency, right there, and there's the y-intercept of the tangent. Okay, so if you were to zoom in, if we zoom in here, then what we can do is we can see that the slope right here of the curve is exactly the same as the tangent line. Okay, we call that local linearity, right? So in that area, if I zoom in enough, the parabola looks linear for a short piece of it, okay? And that's the same as the tangent. And that's the whole idea there, okay? That's the whole idea. All right, so let's go back to where we were. Uh-oh, things are moving all over the place here. This is not good. Let me see. Let's get this back to where it's supposed to be. Right about there. Okay, look at that. Like so. Okay, here we go. So, there we go. Now we're back. So what we're going to do now is go through this process. Okay, so let's find a tangent to this very curve at a location where x equals 2. Okay, we want to find out where x equals 2. That's our goal. And we're going to do that. First thing I've done here is I've listed, there's your tangency equation right there, right? So there's your tangency equation. Let's zoom in on this a bit. So we've got our tangent equation right there. The slope, right, that's f prime at a. Then it's x minus a, which tells you how many times I add on the slope as I go past point A. And then f at a is the y value, okay, so of this graph. Okay, this is just a formula that you're going to have to get to know. It's on your formula sheet, and we'll use it you'll probably use it 50 times, I'm guessing, at least, if not more this year. And if you do calculus next year, probably another 50 or 100 times. So a is 2. That's the x value of the point of tangency, right? And so there's 2 things here that we're looking at. We're going to look at f at a, which is that y value where the tangent occurs, and we're going to look at the slope value, f prime at x, so that's the tangent slope. Okay, so I have the f at x curve. I don't have the tangent slope function. So the first thing we probably need to do here, I'm going to come over to this side, and we're going to get the tangent slope function. So if that's 3x squared, then the tangent slope function is 6x. Then I look at this part here, negative 7x minus 5, and I try to get the slope of that. Well, that's just a straight line part. So the slope of that is just negative 7. Right there, negative 7. So now we have an equation for the tangent slope, and we have an equation for the original function. Okay, remember, just pause, rewind, and at any time. So what we need to do is we need all the pieces in this equation to get our tangent line. So f prime at a, let's get that. So I know a is 2. So I know that f prime at a equals f prime at 2. What does that mean? That I'm going to substitute 2 into the tangent equation, or the tangent slope equation. That's the tangent slope, not the tangent. And that's a really tough one that people get confused with. And you might get confused early on, and that's quite normal. So this equation, folks, describes the slope of the tangent, not the tangent itself. Okay, so I've got this right here. Now what I'm going to do is substitute 2 into the tangent slope curve to get the tangent slope at x equals 2, which we call our a value. So that's going to be, I'm just going to replace that x right there with 2. 6 times 2 is 12, minus 7 is 5. So our f at a is 5. So in other words, the slope of that tangent line is 5. Then I go over and we need to get this f at a. So f at a in this case is going to be the y value when x equals 2 on f at x. Again, substitute it in. 3 times 2 squared. 2 squared is 4 times 3, which is 12. 7 times 2 is 14, but it's negative. So it's negative 14 minus 5 is negative 19. So I've got 12 minus 19. I would do 19 minus 12, which I know is 7, and it has to be negative. So negative 7. So f at a is negative 7. Now really all we have to do is substitute into that equation. Okay, so we go back to our equation right here. Okay, our equation right there. Okay, right there. So what we're going to do is f prime at a is the slope. That's 5. We know our a value is 2, so I replace that with 2. F at a is right there, and we replace that with negative 7. Okay, and so it's 5 bracket x minus 2 minus 7. If I want to, I can expand through the brackets. 5 times x is 5x. 5 times negative 2 is negative 10. And then I've got the negative 7. So I'd have negative 10 minus 7, which would be negative 17. So if you put it into y equals mx plus b, it's that right there. Okay, folks. So again, a nice thing to do is that we can actually take a look over here and see if that's a reasonable, we've got the graph here, so it looks right. Okay, so it looks as though there's our tangent, goes through 2 comma negative 7. Y-intercept is negative 17, which is exactly what we got. The slope is positive, and it looks like it's about a slope of 5. Let's see, yeah, that's about a slope of 5. That's perfect. So 5 over 1 is the slope, and the y-intercept is negative 17. So that works perfectly. All right, so again, it's over now. That example's over now. So again, go back, rewind, go over it. I really think you should fill that in if we haven't done it in class. This is done. I do these just for another chance for you to go over them, or if there's been a snow day or something like that. Okay, so that's a type 1 of the tangent problems.